this would be an example of that vector. If I started at a spot, the -2 in the x spot means I'm going to go back 2, and then the 4 means I'm going to go up 4. So actually let me start down here. And if I went back 1, 2, and then up 4, right there, then this would be that vector that's being described. And you can see how it's back 2 and how it's up 4. But vectors, again, give direction and length, so, or magnitude. So the point of a vector is it gives you not only the amount of force, which we usually do with math, it also talks about direction. So we're adding two vectors together. So the second vector of 5, 0 is going to be just straight over 5 units. 2, 4, 5. That's what that vector looks like. If I'm adding them together, all I have to do is add the x parts together. So the -2 plus the 5. And then the y value, so 4 plus 0. So I'm going to get the component 3, 4 as my new vector. And that would be the sum if I were to add these two vectors together. 26. Oops, sorry, that was 25. This is 26. Write the vector in component form. So you can see it in that little picture over there. You can see how it goes down 4 and back 4. So it looks like this, and again, you're going down 4 there, and you're going back 4 over here. So the component form would be -4, -4. 27. Identify parallel and equal vectors. So equal vectors means same length and direction. Where parallel vectors simply mean they have the exact same slope. They do not have to be the same length. And in fact, if these two have the exact same slope, these two are also considered parallel. So when you look at that, you can say the ones that are equal are going to be vector UV and RS. And the vectors that are parallel in that picture are AB and RS. 28. What is the area of this triangle? So first, we don't know the base length. We're going to have to use Pythagorean theorem. This is actually a Pythagorean triple. But we're using the Pythagorean theorem here to find the missing length. So I'm going to take my hypotenuse is always my C value, which is across from the right angle. So 8 squared plus B squared. So you do a little work. 64 plus B squared equals 289. Divide or subtract 64 from both sides. You get x equals 225, or x squared equals 225, or b squared. And then you do square root, and you get b equals 15. So now I know what my base is. Again, it's just an 8, 15, 17 Pythagorean triple. Now I can use the area of a triangle formula, which is 1/2 base times height. So 1/2 of 15 times the height. Put that all together. Now don't distribute this 1/2 or anything. You can just do 1/2 of 8 even, and just do 15 times 4, which is going to equal 60. And then it's centimeters squared. 29, a parallelogram. They're talking about the area of a parallelogram. You got to know your area formula. It's just base times height. So, so it says the base is 22 inches, and it says the area is 264 inches. So I'm going to substitute 264 in for A. It equals my base, which I know, and I do not know the height. That's what I'm looking for. That's what I have to solve. So then just divide both sides by 22, and you're going to get H equals 12 inches. 30. So now it asks, what is the area of a rhombus? Well, the area of a rhombus, the formula is 1/2 of D1 times D2. So we're going to use this formula here. We're going to plug in 1/2. They give us both the diagonals in this case. So it's going to be 12 times, and then the other diagonal is 18 centimeters. And we can do this because it really falls under a kite also, I think. 1/2 of 12 is 6 times 18. And we are going to go ahead and get 108 centimeters squared. 31. What is the area of a trapezoid? So again, you want to reference your area formulas. This is the area of a trapezoid. The base is B1 and B2. That's the one set of parallel sides. So in your picture here, oops. 27 and 36, those are my bases because that's the one set of parallel sides. My height is 18. And so really, in this problem, it's just a plug and chug. 1/2 of, I'm going to do the height. Actually, let me plug in B1 and B2. So it's 36 plus 27 times the height, which is 18 in this problem. So then now we go ahead and just put this all in your calculator. It looks, if you wanted to be a little savvy, you could actually take 1/2 of 18, and you would get 9 parentheses 36 plus 27. I would add 36 plus 27, and you get 63, and then I would do 9 times 63, which gives you 567. All right. So, we are cruising along here. We still recording? Yep. All right, 32, find the area of the kite. So here we have our area of a kite formula, 1/2 of D1, D2. And in the picture to tell you what both the diagonals are, this is just simply plug and chug. So put that all together, and there you go. 33, the area of a square is 49 square inches. Well, the area of a formula is each side squared. If you think about it, a square is kind of like a rectangle, really, except both sides are congruent where the base is the height. So in this case, usually we would say area of a rectangle and stuff is base times height. Well, here in a square, the base is the same as the height. Those are the same lengths, and we usually just use the letter S to represent that. So if I'm multiplying something by itself, it's S squared. So that's where the formula comes from. It's just rectangle formula, but you're multiplying it to itself. So in the question 33, it tells you the area is 49, so you're going to plug that in for A. And then we have S squared. So I'll take the square root of both sides, and so S has to equal 7. Now it says, what is the perimeter though? So we have to add up all 4 sides to find the perimeter. So if this is my square that I'm using as a sketch, then each side is 9. So the perimeter is just 9 plus 9 plus 9 plus 9, or 4 times 9, and you get 36. 34, what is the circumference? So they give you this circle. Here they tell you this, the diameter that cuts all the way across is 3 centimeters, which makes the radius 3 divided by 2. You got to cut that in half, or 1.5 centimeters, because the radius goes from the middle to the edge. And the circumference formula is 2 pi r. Some people call it C equals pi times the diameter. Either way it works, but traditionally you see it as 2 pi r. So I would plug in 2 pi times 1.5, and you're going to get 3 pi as, or, yeah. Is that diameter 6 in the picture? Sorry, it's a little blurry on my picture. If this is 3 centimeters diameter, then this would be your circumference. Based on the answer key though, it looks like they use 6 centimeters, which maybe that's how that, it's a little blurry in my picture. So maybe that's supposed to be a 6, which in this case would make this a 3, and this would become 6 pi as the circumference. $35. Here we have the circle, and I'm trying to find the area. Well, now we got to use the area formula, and if that's 4 centimeters. So area formula of a circle is pi r squared instead of 2 pi r. So we're just going to plug in 4 for the area, or 4 for r, and I'm going to get 16 pi. Next. 36. So this is a composite figure. So it's made up of two or more shapes. And so we just have to find the area of each one separately. Some of these problems have to be a little creative on how to find the lengths you need, but not this problem. It's pretty straightforward. So I'm going to take the area of the triangle on the left here, and I'm going to use 1/2 base times height. Of course, this is my right angle up here. So I really would think of this as my base. I mean, you can kind of switch the shape over, but this would really be the base. This would be the height of it. So it's really 1/2 of 16 times 30, which equals half of 16 is 8 times 30. That's going to be 240. So the area of the triangle is 240. Now I got to find the area of the trapezoid, which is 1/2 B1 plus B2 times H. You plug that in. 1/2 of all right, so 1/2 of, I'm going to plug in both bases, so 1/2 of 16 plus 40, and then my height is 30. So A equals, I'll take 1/2 of 30 right now and just get 15, and I'll do times 16 plus 40, so 15 times 56, which is 840. And now that's the shape area on this right, so the total area, you're going to have to add those two. And so you get 1,080 feet squared. All right, 37. So the area of a regular hexagon. So this is a multi-step question, really. So regular hexagon, I like to break this up into 6 equal triangles that go all the way around. And we'll just find the area of the one triangle, all right, and we'll be good. So let me just focus on this bottom one. And if I can find the area of this triangle, I'll just multiply it by 6, and that will give me the total area of the figure. So first we have to find our central angle, called CA. And so you see there's 6 sides. It's got to be 360 all the way around. So this is 360 divided by 6, and you're going to get 60 degrees, which makes this a 60-degree angle. Angle. So I'm going to look at this triangle right here, and I'm just going to look at it separately. And I want to find the area of it. Well, I got to find the height. So what I'm going to do is break this triangle actually in half. So that's 30 degrees, and I know, actually in the picture, they tell us half of this amount is 5 centimeters. So right now, if I want to take this half, I can find the area easily and find the height. So this is a 30-degree angle. So we had to cut the 16-degree angle in half. This is the length of 5. And so I'm going to find this height. I'm going to use tangent. Tangent is opposite over adjacent. So the tangent of 30 equals 5 over my height in this case. So I need to multiply both sides by h. Then I need to divide both sides by tangent of 30. So I get h times the tangent of 30 equals 5. H equals 5 divided by the tangent of 30, which you can put that in your calculator. And you get about 2.88. And I just want to make sure tangent 30 is opposite over adjacent. Multiply, so, 5 divided by the tangent of 30 is 8.66. So there's my height. So now if I want to find the area of this one triangle, it's 1/2 base times height. So it's 1/2. And the base, I'm trying to find this whole small triangle right here. So the whole base would be 10. So half of 10 times the height, 8.66. That equals 43.3. That's the area of just one triangle. There's 6 of them there. So the total area of the big hexagon equals 6 times the area of that one triangle, because there's 6 of them.